Simplifying algebraic expressions, division, part 1. So this section is going to be divided into two very short parts. So a few lessons ago we did multiplication. So it makes sense that we're going to do division now. And the mainly division part 1 is going to be set on the second law of exponents. The second law of exponents states that when you have two expressions with the same base and different exponents, so for example, x to the a divided by x to the b, what you're going to do is with multiplication, we added exponents. So it makes sense that when you do the opposite, when you divide, you minus. That's why you get x to the a minus b. A few examples to highlight this. You have 2 to the 7 divided by 2 to the 3. Gives you 2 to the 7 minus 3, which you find the answer of 2 to the 4. X to the 10 divided by x. Remember, if you have no exponent there, there's an invisible 1. So that's going to give you x to the 10 minus 1, which gives you x to the 9. When you have a situation with multiple variables, each variable deals with its own counterpart. The x to the a to the 5 divides with the a to the 2. 5 minus 2 gives you 3. The b to the 6 divides with the b to the 4. 6 minus 4 gives you 2. And that's it. What happens if you get a situation like this? So I have my little trick when I do these. Since it's division, we're doing subtraction. So, alright, let's do subtraction. 8 minus 3, that gives you 5. Where is it bigger? It's bigger at the bottom, the denominator, yes? So you put x to the 5 at the denominator. Since there was nothing left in the numerator, you just add a 1. 1 acts as a placeholder. And there you go, done. You'll see we'll practice a lot more of those in the examples and lessons to come. Let's remind ourselves of the very important rule: numbers work as normal. So if you have 16x to the 16 divided by 8x to the 8, that's 16 divided by the 8 normally, which gives you 2, and you have x to the 16 divided by x to the 8, 16 minus 8, which gives you 8. And then just one more to highlight this. 10 x to the 3 y to the 2 over 2 x y to the 5. 10 divided by 2, which happens normally because they're normal numbers, gives you 5. Now, let's put my little trick to work. This is a 3 and this is technically a 1. 3 minus 1, giving you 2. Where is it bigger? Bigger at the top. So you can put x to the 2 at the top. Y to the 2 and y to the 5. 5 minus 2 is y to the 3. Where is it bigger? At the bottom. And there we go. And now with this rule out of the way, I'm going to quickly go on to part 2 while I have 1 minute left, and to show you part 2 of division, which is dividing a polynomial by a monomial. This brings a rule that I affectionately call the divide and conquer method. So the example here is 4x minus 6 divided by 2. What I do in this case is I break up that thing and divide each one by that same denominator. So I turn it into 4x divided by 2, which gives you 2x, minus 6 divided by 2, which gives you 3. Divide and conquer. And let's do one more example. 12x to the 4 plus 18x to the 3 minus 6x squared y, all divided by 6x. Split the whole thing up into each of its parts and divide each one by that same 6x. 12 divided by 6, giving you 2. X to the 4 divided by x, x to the 3. Plus 18 divided by that, it's 3. X to the 3 divided by x to the 1, x squared, minus 6 divided by 6, they cancel. X to the 2 divided by x to the 1 is x to the 1, and nothing affects the y,